In this video, we're going to be discussing circles. And in fact, before we get into circles, we need to talk about the Pythagorean Theorem, our good old friend from geometry. And we need to also review the distance formula. So let's go ahead and get started. So first of all, hopefully you know the Pythagorean Theorem. We know that if you have sides A, B, and C in a right triangle, that there's a special relationship, a squared plus b squared equals c squared. Now remember, we call A and B the legs, and C is the hypotenuse, one of the more mispronounced words in mathematics. It's not hippopotamus. Let's look at the distance formula. It says given 2 points, x sub 1, comma y sub 1, and x sub 2, y sub 2 on a graph, the distance between the points is, well, the formula is d equals the square root of the quantity x sub 2 minus x sub 1 squared. Now, don't get too impressed with that. All that is you're subtracting the x values of the points. And then you have plus the quantity y squared minus y sub 1 squared. And that's just subtracting the y values and squaring that. And so I'm going to go ahead and do that with these 2 points here on number 1. It says find the distance between the point 2, 1 and the point 7, 4. And so let's go ahead and plug in our numbers. So first of all, x sub 1, y sub 1, I'm going to call that the first point, 2, 1. And x sub 2, y sub 2 will represent the second point, 7, 4. Now it really doesn't matter which one you call the first or second point. And really that's all those subscripts mean. You've got 1 point and you've got a second point. All right, so let's go ahead and plug in, I call this a plug and chug situation here. Let's go ahead and plug in the numbers. And so if you subtract the x sub 2 minus x sub 1, notice that's 7 minus 2 here. And we're squaring that plus, and then let's subtract the y values here. Notice y sub 2 minus y sub 1, that's going to be 4 minus 1. And so we get 4 minus 1 squared. And so we're going to get 5 squared plus 3 squared under the radical here. Of course, 7 minus 2 is 5, and 4 minus 1 is 3. And so that's going to give us 25 plus 9, which is the square root of 34. So the distance between these points is the square root of 34. Now, this is a radical expression. It is simplified, but you know, there's a good chance you'd probably want to give a decimal approximation. If we did that, you would use your calculator. But let's go ahead and look at the points on the graph, and let's see where this distance formula is, or how it's basically, how are we getting this formula here. So I'm going to go ahead and put in the points 2, 1, and 7, 4. And of course, the distance between that line there, or that segment, line segment, is D. Now what we can do is we can make a right triangle out of this, as I've just done here. And now here's the thing. Remember, the first thing we did in the formula is we subtracted the x values and we squared that. Well, why did we subtract the x values? Well, we want to know this distance, and in fact, don't we subtract the x values to get that distance? 7 minus 2. There are 5 units there. And we can do the same thing for the vertical segment here. We subtract the y values though. That would be 4 minus 1. And so we get 3 there, and we can see that that's 3 units. And so this is what's happening here. So now remember, we can square the 2 legs, and that should equal the distance, or in this case d squared. So we would have 5 squared plus 3 squared equals d. If I take the square root of both sides here, notice that's what we have here. This was d equals. All right, so hopefully that makes a little sense. That's what's going on here. I'd like you to try number 2, and then you can check the video to see if you did it correctly. All right, so there's our distance formula. When you plug in the numbers here, you should get the square root of 3 minus negative 2 squared plus negative 1 minus 5 quantity squared. You end up with 5 squared plus negative 6 squared. Again, when you square a negative, negative 6 times negative 6, you're going to be positive. So it really doesn't matter whether we're positive or negative. When we square, we're going to get a positive. So you get the square root of 25 plus 36, which is the square root of 61. All right, let's move to the next slide. So for circles here, it says the definition, a circle is a set of points in the xy plane that are a fixed distance r from a fixed point hk. The fixed distance, and in fact, I mean, if you wanted a picture of that, it'd look something like this. We're basically saying each of these points on the graph of that circle is the same distance from the center, which we're calling hk. All right, so let's see. So hk is the center, and we said r is the radius. Equation of a circle. So the standard form, we're right here, the standard form of the equation of a circle with center hk and radius is the quantity x minus h squared plus the quantity y minus k squared, and that's equal to r squared. And in fact, if your hk is 0, notice if you plug 0 into the formula I just gave you, you would have a circle that's centered at the origin 0, 0, and the equation in this case is x squared plus y squared equals r squared. Now hopefully you can kind of get a feel for the fact that this is just a result of the Pythagorean theorem, and it's basically the same kind of stuff we were looking at on the first page. So let's go ahead and do some problems here and see how we work with circles. So number 1 says, write the standard form of the equation of the specified circle. So we have a center of 0, 0 and a radius of 4. So that tells me I'm going to be using the formula x squared plus y squared equals r squared. Notice here our radius is 4. Of course, 4 squared is 16. And so the equation is going to be x squared plus y squared equals 16. Now, if you want, you can try part B, and again, then watch the video. So notice here, we're not going to be using the same formula that we used in A because our center is not 0, 0. So the first thing I would do is write down the standard form of an equation. Now, by the way, you do need to know these formulas for the first test here, so you want to get to know them. So in this problem, our hk, our center, is the point negative 3, 2. So h is negative 3 and k is 2. And so again, this is a plug and chug situation. We're just going to plug in the numbers and simplify. So our radius here is square root of 13. Let's go ahead and plug everything in. We have x minus h. Now notice we're subtracting a negative there, x minus negative 3, quantity squared, plus y minus k. Well, in this case, k is 2, so it'd be y minus 2 quantity squared equals the square root of 13 squared. So this is going to become x plus 3 quantity squared plus y minus 2 quantity squared equals 13. Now think about this here. Where did I get that 13? You know, if I said double a number, so think of any number and double it, and then I said take half of what you just got, wouldn't you get back to where you just started? That's the idea here. Squaring and taking a square root are opposites. So if I take the square root of 13 and then square that, I get back to where I started, which is 13. So that's the idea here. All right, so the next question, number 2, says find the center and radius of the circle and sketch its graph. So we're actually going reverse of what we just did. So if x squared plus y squared equals 49, well, we know that, let's see, what did I just do there? So we know our center here is 0, 0. And of course, r squared is 49. Well, we know 7 squared is 49. So our radius is 7. All right, and then notice it did ask us to sketch the graph. So we need to draw a circle centered at the origin with a radius of 7. So it would look like that. All right, let's look at B. So I have x minus 2 quantity squared plus y plus 5 quantity squared equals 9. The first thing I think I would do is write down the standard form, x minus h quantity squared plus y minus k quantity squared is equal to r squared. So in this case, you can see h is 2. Now be careful with k. We have y minus k, but it's a y plus 5. So if you said k was 5, that would be wrong. We don't have y minus 5, so it must be negative 5. It's the opposite. And of course, r squared is 9. That means r is 3. So we need to draw a circle that's centered at 2, negative 5 with a radius of 3. It's a little bit difficult without having a nice grid to work with, but it should look something like this. All right, so I would encourage you to try 3 and 4 and see if you can figure those out. 3 is a little bit more challenging, but you've got everything you need in order to do that problem based on what we've done so far. All right, so let's look at 3. It says find an equation for the circle with a center of negative 1, 4 and passing through the point 3, 7. Now the thing is, we have the center, which we need, but we also need the radius. Now think about what we have here. We basically have the center of the circle, and we have a point on the circle. And so to find the radius, we need to just find the distance between those 2 points. And so that's what we're going to do here. So first of all, we're finding the distance between the 2 points. So I'm going to use the distance formula. And I'm going to plug in my numbers. I'm letting negative 1, 4 be the first point, x sub 1, y sub 1, and 3, 7 will be the second point. And so I'm going to go ahead and plug in those numbers. And so when you do that, you're going to end up with the square root of 4 squared plus 3 squared. And that's 16 plus 9, or the square root of 25, which is 5. And so now, remember, that's our radius, 5, and we already have the center, so we're going to use the center negative 1, 4 with the radius of 5 to write the equation. So I'm going to go ahead and write the standard form, x minus h quantity squared plus y minus k quantity squared equals r squared. And I'm going to plug in my h and k, and I'm going to square my r, and you get x plus 1 quantity squared plus y minus 4 quantity squared is equal to 25. Now on the last one here, you can see by looking at this graph, so we're supposed to use this graph and write the equation of the circle. So first thing I notice here is it's pretty evident that the center is the point negative 2, 1. Now what about the radius? Well, if I draw a radius, you can count the units there, and that's going to be 3. And so that's all we need to write the equation. So again, I'll write the standard form of an equation. I'll plug in the point negative 2, 1 as my center. That's my h and k. And we're going to square the r, or square 3 here. So we get x plus 2 quantity squared plus y minus 1 quantity squared equals 9. And that's the end of this video.